everybody. I'm Earth.Otherwise, and today, and for many days to come, I'll be looking at the book Game Programming in C++, Start to Finish by Eric Yuzwa, for the purposes of assisting both myself and others in the absorption of its ideas. This exercise will act as a comment upon, criticism of, and supplement to the book itself, as well as a kind of tutorial series using the book as a foundation. I'll be reading out passages from the book, but they will be quite abridged. This first post will act as a kind of glossary for the series and the book. Firstly, it should be noted that this book was published in 2006, meaning that, at the time, it was using SDL 1.2 and OpenGL 2.0. As of the writing of this post in 2017, we currently have SDL 2.0 and OpenGL 4.5, meaning that all of the specific code of the book is now depreciated. This is stacked on top of a review back in 2006 that the code was difficult to run even back then. I will be going into this assuming that all, or almost all, of the code in the book is completely useless. However, other reviews and my own perusal find that the book has a fairly good grasp on the foundation and principles of making a game, and generally that knowledge is fairly timeless. So, my goal here is to look at the foundation, look at the original code, and make sense of it so that I can help myself and hopefully help you to make video games. The posts will be split into two types. Foundation posts, which will be readings from the book and my thoughts. This will not be code specific, hopefully, so it should be useful for a long time to come. The second type will be code specific, using my own knowledge of OpenGL, SDL, and C++ to use the foundation knowledge to make a concrete program. So, let's take a look at what we have in store for us. The book is split into 21 chapters, each chapter having a number of subchapters. The first chapter is on game technology, and includes some technologies that Yuzwa found useful, including concurrent versioning systems, Doxygen, and something called InnoSetup, and the standard template library for C++. The second chapter is on design fundamentals, like the iterative design that most games use, and the classic waterfall design that most software outside of video games used. It also gives an introduction to the unified modeling language, which I'll have to look up, and some advice on notation. Then it goes on to the reusability of code and design, followed by the anatomy of a game and the design document for a game. An asteroids clone in this instance. This game will be using that design document, and using the game itself as a kind of end goal. It then goes over a few other things that we'll get to when we begin that chapter. The third chapter is looking at SDL and Windows. We'll look at this chapter, but since this is the old SDL that was talked about in the book, we will either skip most of it, or I will look up the modern equivalents of what the book is talking about, and I'll explain that. Or I might just point you to the Making Games with Ben YouTube series that I learned SDL from. If you're watching this in the future, that is after 2017, you may want to find tutorials yourself on how to use SDL. Chapter 4 is an introduction to the Peon engine, the game engine that this game teaches us to make and use. Likely, much of the specific code for this engine is useless, but we might be able to find some designs or code snippets that might be useful in the Otherwise engine that I use, which I remind everybody is just a version of the Benjin from the YouTube series mentioned earlier. Chapter 5 is on graphics programming mathematics, and I've heard that this chapter is pretty good and goes in depth, talking about coordinate systems, fixed function geometry pipelines, vectory, I don't know if I misspelled that, and matrices. It also talks about OpenGL matrix stacks, something I'll have to look into to see if it's still relevant and usable, or if there's a better option now. Following that, there is matrix manipulation, some text on transformations in 3D and 2D space, and some camera and view orientation. Chapter 6 and 7 are on OpenGL. Likely, it will all either be out of date or useless. I'll read through it and also read through current OpenGL documentation in order to hopefully get the best understanding on OpenGL for use in game programming. Chapter 8 is about scene geometry management. It talks about things like depth buffers, frustum culling, rendering states, etc., followed by a specific scene graph in the book, engine, and oct trees. Chapter 9 is the graphics time box. We will get to that when we get there, but it's essentially about asking ourselves what we can do graphically and then measuring out what time we'll put into it. Chapter 10 is about input devices. We will look at it, but I'll also be talking about how the current version of SDL handles getting inputs. Chapter 11 and 12 are on sound. They introduce OpenAL. I'm not sure if I'll go too far into that, since I'm not familiar with OpenAL, or if I'll even want to use it for sound. If I find that a different set of code works better for sound, then I will mention it. Chapter 13 is on physics and collision. It talks about bounding boxes and spheres, plane and ray collisions, and implementing physics. The book uses something called the NE simulator, but Ben used something with box physics. I will most likely look at other physics simulations for 2D and 3D games using C++. Chapter 14 and 15 are on networking, something that I have zero experience in. This will require a lot of research, since I'm sure much of the code and perhaps even the ideas are no longer used. The chapter talks about peer-to-peer and client-server networks, direct play, and WinSock, the networking that SDL can do, servers, IPs, and server-side prediction. You may recognize some of these things from game design talks. I will have to go over more of them in detail in that chapter. Chapter 16 is about models, including generating them, meshes, and something called collada. I get the feeling that much of this chapter is going to be useless, as modeling software has come a long way since 2006. At least, I would hope it has. Chapter 17 is about animation and special effects. It covers billboarding, skyboxes, object picking, particle systems, shockwaves, and screenshots. Chapter 18 is on the OpenGL shading language. I will skim through this chapter, but mostly do independent research on this topic, since I think the OpenGL shading language has changed since 2006 as well. Chapter 19 is on scripting, another thing that I have little experience with, though that I have heard that scripting languages are incredibly important, unless of course you want to hard code every tiny detail into your game. I personally like to believe that versatility is something that should be looked for in video games, particularly PC indie titles. The final two chapters are on polishing your game and tips for finishing your game. We'll read these pretty much in full, since they probably won't be very code-heavy. 21 chapters, 350 pages, and no doubt dozens of videos. Well, let's get started. I will have released the first foundation video along with this introductory glossary, and I will be putting all the videos on this subject in a playlist on YouTube, and they will be tagged the same way on my blog. Links to that playlist, the Amazon page for the book, and various other things down in the doobly-doo. Thank you for joining me. This has been Earth.Otherwise, signing off.